Taking what we learned in the earlier example, we have a new ruler, a new device, and we see the scale as enumerated. So we have our labeling that goes like so. And what we saw in the previous examples are that there will always be an additional 0 on the labels because we'll be estimating another decimal place. And if we were to go further, we can label this inside. Since this is a halfway mark, this would be 0.065. 070,075. And here we have 085. And here we have 095. And then here we would have 105. So now using the ruler to measure the light blue, we can see then that counting these off, this is 084, 83, 82, 81, and again 80, which we have there. 86, 87, 88, 89, 90. So the blue comes down here like so, and it is more than halfway, and we might say that is 8. So this is 85, 86. This would be 858. Zero point 858. So writing out that number, it would be 3.0858. It is more than 85, less than 86, so that's 858. Notice the labels here, 4 digits, 4 digits, 5 digits. Now we go to this next one. It is on the mark. Now we said this is 090 and 095. So this is 091, 092, 093, 094, 095, and it's exactly on the mark. This is 096, and we're saying it has no more of these additional marks. So the measurement would be 3.0950. It is between the 095 and the 096, but it is exactly on the 095, 0 of those extra little divisions. Moving on to the magenta, 0.097, 0.098, 0.099. And this is 0.100, 0.101, 0.102, 103, 0.104, and 0.105. We say it is exactly on this 0.100. And there are no additionals. So it is 3.1000. If this is 101 and this is 100, there are no more additional tenths. There are 0 of those tenths. So we notice, as we saw previously, this has 5 digits. This has 5 and this has 5. They all agree to the same decimal place, the 10,000th place. There's an agreement because they're all measured using the same device. Now, where students can be confused is in this 0. these zeros over here. Let's start with this one. This 0 is a significant digit. It just so happens in the 10th place there are no tenths, so it's 0. Similarly here, the 10th place. 10th place is 0. There's just no tenths. But this is also significant because we're saying there's no 10,000ths. So both these two digits are significant. And lastly, the one that gives students the greatest difficulty is that all three of these zeros are significant. What we are saying here is that we could report an answer to the 10,000th place, but it just so happens because of where it falls on our scale, there are 0 hundredths, 0 thousandths, and we think it's right on the thousandth line, so there's 0 10,000ths. All of those numbers have 5 significant digits. .0858. The black is 3.0950. And the last one is 3.1000. All have 5 significant digits. And what we're reporting is that the rightmost digits are estimates. And the second rightmost digit is the increment. And that's what we saw to the thousandth place, In our next installment, we will talk about bias in measurements. When there are judgments to be made, it is possible for there to be bias. In the next installment, we'll talk about how to avoid bias in measuring and estimating scientific quantities.